Hello everyone, my name is Shambhavi. Hope you all are doing well. So basically in this video we are going to discuss regarding the matched or paired samples. That basically what are these matched or paired samples, that how are they used and what to use in this particular topic, and all the things are the things that we are going to discuss in this video. Right, let me just put on the topic first of all and let me take out the color. So here we have the color and that is actually matched or okay, that is matched or paired samples, right? Yeah, this is the topic for the discussion of today. So here I'll be mentioning out some points as well, and I'll be mentioning out some formulas as well into this particular topic. Let me just quickly take out some color for writing out the things ahead, and then we can just absolutely move ahead with this particular thing. So let's get started, and my number for topic 1 number will start here. So first one is basically my random simple random sampling is used. So the very first thing regarding this is that the simple random sampling is used. So whenever we just go and solve out the question regarding the matched or the paired samples, okay, so in that case the simple random sampling is used, right? This is the very first thing that we actually have out here. Moving towards the second one, we have the sample sizes. So here comes regarding the sample sizes. So the sample sizes are often small. So into this particular one, that is matched or paired samples, the sample sizes which are there that are often small. Okay. Then we have that two measurements, um, two measurements or you can just call it as samples. Okay, two samples are drawn from the two samples are drawn from the same pair of yes, so from the same pair of individuals or objects or individuals or objects. So whenever we talk about the two measurements in this, so the two measurements are drawn from the same pair of individuals or the objects. This measurement is as per the samples only. So I could just like put out the statement in this way, that the two samples are drawn from the same pair of individuals or the objects, right? So let me put out a dot here. That's over. Right. Now, what about the next points which we are having? So, point number 4 comes here and it says that the differences are calculated. Differences are calculated from the matched. Differences are calculated from the matched or paired paired samples. So samples, right? So whatever the differences we are having here, that are calculated either from the matched or from the paired samples, right? This is the use for the matched or paired samples. After that comes the next point, that is point number 5. So here comes that the differences form the sample. Let me come down, get out some space for writing. Yeah. So differences form the sample that is used for the hypothesis test. So the differences that are formed of the differences from the samples that is used for the hypothesis test. Right, so basically just have a look here on the last point which we have mentioned, that differences are calculated from the matched or the paired sample. That is absolutely okay, right? That whatever the differences are there, these are calculated either with the matched or the pair samples. And whenever these differences are calculated, so the differences form out the samples that are basically used for the hypothesis test. Got that? So this is the whole idea regarding that matched or the paired samples, right? This is the idea. After that, we even have some more thing for this to discuss out. Let me just go ahead, get out some space for me. Let's write out the 6th point. This is the last point actually. Okay. So into this point, it says that the the matched pairs the matched pairs have differences that have differences that either come from a population that is normal, or the number of differences is sufficiently large, so the distribution of the sample mean of differences is approximately normal. Right, so the matched pairs have differences that either come from a population that is normal, or the number of differences is sufficiently large, so the distribution of the sample means of differences is approximately normal. Right, this were some of the little, like, some things and some points regarding the matched or the paired samples, right? That the simple random sampling is used. Second one, sample sizes are often small. Two measurements are drawn from the same pair of individuals or the objects. So here the measurements for actually the sample. So I could just actually say that the two samples are drawn from the same pair of individuals or the objects, right? Differences are calculated from the matched or paired samples. The differences from the sample that is used for the hypothesis test. The matched pairs have differences that either come from a population that is normal, or the number of differences is sufficiently large so that the distribution of the sample mean of differences is approximately normal. Right, so hope you just got the idea regarding whatever I just mentioned out the things right here. Fine. Okay, after that, it's not like totally completed. I have some more things to tell you regarding this particular topic only. Yeah, listen to me. Here, basically, whenever we do a hypothesis test for a matched or a paired samples, so basically, subjects are matched in pairs and the differences are calculated, right? These are some things which we had already written out onto the above like points. So the differences, basically, what are the differences? Differences are the data, right? Which I just mentioned, that the differences are basically calculated, the subjects are matched. What is our differences? That differences are data, right? Which will be getting out from there. As soon as the differences are calculated, again we just get out some data, right? Now, basically the population mean for the difference is then basically tested using a student's t-test for a single population mean. After that, after finding out that differences, that is the data actually, what we do, we basically take out the population mean for the difference, and that is basically tested using the student's t-test for a single population mean, which will be having n minus 1 degrees of freedom. Okay, and basically what is the n is basically the number of the differences. So the t score or the test statistics, basically what we have, that is t is equal to uh, xt bar minus mu d divided by sd upon under root of n, right? So this is the formula which would be actually coming. So what is this mu d? Actually, this mu d is the population mean for the difference only. That mu d will be tested using out the student's t test, right? So this is the idea regarding out this particular matched. Okay, just one second. Let me go ahead above once again. Yeah, this is the idea regarding the matched or the pair samples which we actually have out here. So in this, basically a simple random sampling is actually used out in the matched or paired samples. After that, sample sizes are often small. Right. Then the two measurements are drawn from the same pair of individuals or the objects. Differences are calculated from the matched or the paired samples. The differences from the sample that is basically used out for the hypothesis test. The matched pairs have differences that either come from a population that is normal or the number of differences is sufficiently large so that basically the distribution for the sample mean of differences is approx normal. Right now, what about the t-score? So first of all, I just told you some things orally. Let me just repeat that out here as well. So in a hypothesis test for a matched or the paired samples, subjects are matched in pairs and the differences are calculated. Let me put on here that the differences are calculated. Differences are calculated. And what are these differences which we will be getting out? These differences which we'll be getting out is basically our data. The differences are the data actually, right? Now, actually, when we're in the next video, basically we are just going to see one example for this particular thing. There you'll be getting out two columns. And from that two columns, we'll be making out a third column that would actually contain out the differences of the first two columns, right? This is the idea. Okay, after that, basically for calculating out the population mean for the differences, so in that case mu d was a variable which we had put on, and like the symbol or the denotation you could just actually say. So that is basically tested using out the students t test for a single population mean, which would be having n minus 1 degrees of freedom. What's the degrees of freedom? We had really learned this thing in a too much detail into the previous video. So I'm just not going to repeat out these things again and again in the further videos. So if you have some doubt, you can just go back and again have a look over that particular video. Right? Yeah. So n minus 1 was basically the degrees of freedom, and what was n into that? So n is basically the number of the differences here, right? So this is actually all set, and after that we saw out one formula regarding that test statistics or the t-score. So let me just first of all put on some highlighter into my hand so that I could just highlight the things as well. So yeah, t is basically equal to x bar d minus mu d upon sd into the bracket sd upon under root of n, right? This was the formula which we had seen. Now into the next video, when we solving out the question, we're putting out the values. So in that case, in that place only, I'll be telling you that how to put out the values onto these particular things which we are actually given out here, right? So hope you got out this topic very much clearly regarding the matched or the paired samples, right? So this is all for this video. Till then, thank you and take care.